Alright, we have construction going on here, so there's a lot of background noise. I apologize for that. So now today we're going to do the macroscopic and microscopic concepts, and we'll invite Dr. Chan to continue, please. Thanks all for coming. Before I begin, I'd like to give special thanks to the AWE working team, and especially Dr. Low for his guidance. And this lecture is actually built on the shoulders of giants. Special thanks to Albina and Ruby and Jenny disappeared on us. Okay. Now, this is really an extension of what we have learned up to this point. Okay. In the first lecture, Dr. Low mentioned about fragmentation of knowledge. And I'm going to try to build on that theme today on this seminar. On the last lecture, we talked about how to count numbers. Well, numbers are constant. It doesn't have a unit. So today, we're trying to add something special to the concept of large numbers. So we'll add some units to it, okay? And let's have some fun out of it. First slide, please. Now, on the top, it says the 10th power. Is there anybody who has difficulties understanding what we mean by 10th power? No. Okay, I assume no hands up is yes? All right. So from the macroscopic to microscopic, the 10th power. All right. Next slide, please. Yay, my favorite. Now I have to read this one, okay? So let's buckle up, okay? We're going to fly. So it's starting from 10 to the power 0, which is 1 meter. We're adding a unit to it, okay? We're adding meter to it. That's a measurement. Before we just 10 to the power 0, which is equal to 1. So we'll increase by the distance, 1 dimension, by the power of 10. So 10 to the power 1, 10 meters. 10 to the power 2, 100 meters. 10 to the power 3, 1,000 meters. 1 kilometer, okay? Like remember last lecture we say about adding a unit to it, adding a unit to it, adding a name to it to make it more familiar. Alright? So we are doing the same thing building on the last lectures. 10 to the 4th power, well, 10 kilometers, right? Which the basic SI unit is 10,000 meters, okay? Now, in case anyone doesn't know what SI unit is, that's the International Standard Unit, which is defined, which has no simpler units to it, okay? And then until we come to cosmic, macroscopic, infinity. Is there such a thing as infinity? We talked about that last time. Infinity is basically for an unenlightened simple man like me. When it goes to billionaires like Warren Buffett, I love that. Okay, so that's infinity. So we have gone through that concept. And again, today's lecture is built on what we have already learned. From our starting point, we shall travel upward quickly with a speed increased by 10 to the positive power. So that's 10 to the power 0. You know, I remember seeing a movie. I think you have all seen it too. One day this young boy was, happened to be in a spaceship. He said, I want to leave this planet which is really not happy. So take me 20 miles away. No, 20 kilometers. So zoom, he was 20 kilometers away. The guy said, well, where are we? Well, he said 20 kilometers away, right? So the robot said, he meant 20 kilometers up. Not that way. So that's why he couldn't recognize a thing. Oh, sorry, kid. You know, you went to the wrong dimension. So we go up that way. Now, and then when we move positively, that means get bigger, bigger, and then we'll go negative power. Now, negative power is not really negative. It's just getting smaller and smaller. That's a technical mathematical term, okay, which can be very, very confusing. So until we reach a magical level, all right? Well, now this red part is interesting. Please be carefully observe the first law of thermodynamics. Please also contemplate, as human, how much more we need to learn about our universe. Now, remember last time we counted 10, so we can broaden our horizon, open our mind. This is actually a continuum. If you look at our lecture numbers, this is school number 3. We are still continuing with the same concept, all right? So last lecture We really drill on that concept of infinity, expanding our horizon, opening up our mind. So this is basically building on the same lecture. And that's what Dr. Low had been saying all along. Let's go one lecture at a time. Let's not skip, and because it will be tougher and tougher, and we skip more and more. Okay? But in case you really have to miss a lecture or two, please come back and we will try our best to help you. Okay? By the way, anybody who doesn't know the first law of thermodynamics? No, neither do I. Never mind. Okay, I remember learning it in university, but I only remember the second law of thermodynamics. You cannot create anything out of nothing. Then I realized thermodynamics is wrong when it comes to humanity. All right? You want me to digress a bit into why the second law of thermodynamics is wrong? Okay, second law of thermodynamics is you cannot get output, okay, without input. Okay? Which is fair. Then I don't realize, starting from Trudeau, he broke second law of thermodynamics. Pierre Trudeau. His son is trying to be the, head of Federal Liberal Party, right? Pierre Trudeau broke the second law of thermodynamics. He's a genius. He created a generation of people who got something out of nothing. That's called welfare. Agree? Right? Yes. No output, get input. Yeah, politicians are great. All right. Yeah, just digression. Okay. Next slide, please. All right. Are we ready to fly? Yes. Let's go. Well, where are we now? All right. Okay. I assume you're ready. Okay. So, 10 to the power 0. Our day-to-day life. All right. Which is 1 meter. That's how much we can see. Just about a meter. All right. Next one, please. All right. So we are going 10 meters now. So we're going by meters right now. Okay. Later on, you'll find it exciting. At 10 meters high, we see a cluster of vegetation. Now, we all have seen this on Google Maps, isn't it? Most of us have tried to Google and then we'll zoom. Oh, that's my house. Yep, I can even see my son waving at me. It's not true. He's not there. All right, next one, please. All right, so we're going higher now. Remember the story? So flying out that way, we're going straight up, okay? Now, we're beginning to see the border of the vegetation. And is it a school, is it a gym, or is it whatever? It really is unimportant. We are just going higher now. So we have a better view of a bigger picture. But everything gets smaller. Next one, please. All right. We are a little bit higher now. We are 1 kilometer. We are beginning to see a bird-eye view. Well, actually, the birds can fly higher than the parachutes, okay, except for this guy who jumped from the sky, right? Now, whoever can see the slides right now, so we are saying we now switch from meters to kilometers. So we are going to magnify our speed and micro and minimize our view, okay? So we go actually 1,000 times each slide now. So it's not like boom, boom, we go boom, 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 okay? So we are, I am sure I won't get charged for not buckling up. You really have to look at what first law of thermodynamics is. I think it's input equals to output. The amount of energy that we put in equals the amount of energy that comes out. That's probably first law of thermodynamics. But how is that different from second law? I know one of the laws is called entropy. I thought initially when I read about entropy, I thought it was the thing that we eat. We're getting close. We're beginning again. So,
up and down.
yeah, we're going up and down. We're not going across. Okay. So we're going to continue. Now, we are even higher now. We're beginning to see the states. I mean, every province, every state. So we cannot distinguish city now. So we are at 100 kilometers up. We're not at the level of satellites yet, I think. Now we're beginning to advance to the level of satellites. Maybe that's why the astronauts are so humble. They have seen much bigger view than average human can see. All right. This is what astronauts will see. So part of the northern and southern hemisphere. We go one step higher. Oops. This is when we are going to the moon. Right? So this is 10 to the 8th power, 100,000 kilometers. Now our units are really jumping fast now, okay? The Earth is getting smaller and smaller. Now, the white ring around that little center is the orbit of the Moon. This is what the Mars module will see when they are traveling towards Mars. This is somewhere that no human has gone, because the astronauts has not gone to this yet. They went no further than the Moon. From there, now we are actually so high up that we can actually see the orbit of the Earth, which is the blue line. We go one step further. Now take a look at the units. We're talking about millions of kilometers, right? So instead of kilometers, we're going by millions. So we're jumping very fast. This is a log scale. So instead of arithmetic progressions, we are talking about geometric progressions. We are beginning to see the orbit of the Venus and the orbit of Jupiter, okay? Because those are the ones that's nearest to us. So we go higher. Good. We're beginning to see more and more of the planets. Right? We have Mercury, Venus, Earth, and Jupiter. But where's Mars? How about Mars is next? All right. We're talking about billions of kilometers now, okay? Went from millions, thousands, millions, we're going to billions of kilometers. So from here, we can see the solar system. Actually, one of our satellites has gone that far. I think we have one satellite that has already left our solar system. The Americans are incredible that way. They have built one. Now, we are so high up now, we're talking about billions of kilometers, 100 billion kilometers. We are beginning to see our whole solar system. You know, look around the solar system. We have all sorts of stars. We are only somewhere in there. Now, remember what this lecture is about, right? Microscopic view, built on counting sand. We are building up the same type of concept in a way. This is 100 billion kilometers. Now the solar system looks just like one of the stars. And how many stars are there? I can't count. Maybe I should. Now, solar system, we're talking about, look at the units. Look at the unit. We're talking about light years, okay? We're talking about how long it takes the light to travel. Again, we're looking at units. This is meters, kilometers, all right? Light year is actually a dimension. Light year is actually a distance. It's a unit. It's a unit and a number, okay? So to us, that's infinity. But again, it is really a dimension. Now, so let's go again. See, 10 to the power 17 is still a number that we can relate to, okay? But in terms of real terms, that's probably we lost ourselves in it, okay? And it is somewhere that no human has ever imagined that we will travel, or we have traveled. Someday we may, but for now, it is just basically an abstract. So we're talking about 10 light years. We cannot even see our own solar system. All right, stars and nebula. There's nothing. I love the word nothing. There's nothing. All we can see is stars and nebulas. Is there really nothing? Okay, we went through that concept of nothing last time. Okay, it's nothing when our mind has already blocked. Our mind just cannot think any further. That's nothing. And nothing is really not nothing. All right? There's a lot of contradict terms, a lot of concepts that can be confusing, but after last lecture, I think we understand what nothing can mean, being nothing. Right? Okay, this is 10 to the 18th power, 100 light years. The Milky Way, we actually are outside the Milky Way, so we can look back and see it. That is only 10 to the 19th power. All right? We're talking about how long is it, right? You know what that is? The Milky Way. Oops. 10 to the 20th power. Okay? So that's 10,000 light years. All right, so we continue to tour the Milky Way, and we go outside the Milky Way now. Then we go further. I think we can still go further. Oh, wow, what's that? That's what something I saw in the museum and the planetarium. All right. So we're actually taking you way beyond what we can imagine. So we are at 10 to the 22nd power, million light years. Next one, please. All right. 10 to the 23rd power, 10 million light years. All right. Our imagination can go on and on and on. Every part of the universe is governed by the same physical laws. Otherwise, it wouldn't be called physical law. Now, we can travel further and further because there's really no limit on where we can go based on the last lecture. Again, we go back to the original beginning of our lecture here is that we are trying to broaden our horizon, showing us other than counting sand and outside the reality of this confine of our day-to-day activities, we can actually look into the night sky and appreciate a lot. All right? So let's go back. Okay? Now, we can go back very quickly. This is really the same slide that we had seen. So we'll be flying back. I'm not going to interrupt your journey home, which is always pleasant. Nice to set foot in the reality of the ground. The ground. Well, remember the relaxation exercise that we were seeing? Yeah, we want to rest our feet on the ground because we want to feel the solid of the ground. We want to feel the chair that we were resting on. It's so nice to be able to have a comfortable chair that we can feel a bump sitting on it. So we are coming home. Florida. Okay. 10 to the 30 kilometers. Okay, folks? All right. Coming back to life. Coming back to reality, right? Reality. Somewhere that we are at. So we are back to seeing the schools, the vegetation. All right. Can we stop here for a second? We're back to Earth. Back to where we are. Back to our own perception. Our own day-to-day activities. Now, any questions up to this point? Or we just travel too fast? Yeah, please.
I just have a question.
Yeah, please.
We never been there before. How do you know? We just kind of imagine that our galaxy.
Yeah.
But we never know if it's real or not. Right?
Yeah, you are so right. Because no man had traveled there. So it's really based on astronomers and how they perceive it. Well, in fact, maybe some man had traveled there before, like Buddha, Jesus, and all those. They might have, but not in the human sense. Dr. Lo, do you have anything to add on that one?
Yes, actually, it's not just pure imagination. It is based on many spectrum. We now have very, very powerful telescopes that look way into the many light years away. These telescopes, we use different color spectrum. So you can look at your infrared spectrum, you can look at many, many different spectrum. And with the powerful computer software, we can actually calculate, as we look into space, we're actually looking back in time, because this is how long ago this light has traveled from the other side of the universe back to Earth to be seen by our telescope. So you back calculate those distances, in terms of time, in terms of space, in terms of this and that, okay? There's plenty of that. Now, to really answer your question is in year 4. When we go to year 4 of this curriculum, year 4, semester 1, we will go deep into how exactly all the physics, chemistry, biology, astronomy establish all this reality. All right? So the question is a little bit 4 years ahead of time. That means you are more enlightened than most of us.
And congratulations. See, that's a great part about being in a setting that we can discuss. Now, I learned something from you. I learned something from everybody. Even the one who's sitting around will generate energy that would help us. Thank you. By the way, just interestingly, I haven't asked this question. I just heard about it. Just out of curiosity. Why is the night sky dark? Right? The answer was given to us already. Why is the night sky dark? Dr. Low just gave us the answer. All right, next slide, please. So we're going the other way now, okay? The other way is not down, it's actually smaller, okay? Down means smaller in this case, all right? Now, we're beginning to see the veins in the leaves. So we are going microscopic. So minus in here means smaller, all right? Does not mean negative. Negative means nothing but smaller, okay? Next, please. Now we're going centimeters. 1 centimeter. So need a microscope to see it. Again, even smaller now. 1 millimeter. Smaller than a centimeter. Okay. We are beginning to see the cellular structures. Really? Getting smaller now? A more powerful microscope will bring us this. Now, by the way, the unit has changed. It's called micron now. Okay? Micron is 10 to the minus 6 power. Our journey inside the cell. Now, again, it's not negative, okay? It is still just meaning it's getting smaller. All right, we're beginning to see the cellular structures, the nucleus of the cell. Wow. We are seeing chromosomes. Chromosome is what kind of shape our beings, but it is not the smallest structure yet. We are going to see the DNA, which is really what built human being and built all the living creatures, DNA. Now, this unit is called angstrom. It's actually an old unit because these days we use microns. 10 to the minus 9 power is micron. So this is angstrom. We are seeing the DNA change. So we're going further in, getting smaller and smaller. This is really something you need an electron microscope to see it. Not your everyday eye can see it now. Wow. Where are we? Okay, 10 to the minus 10, 1 angstrom. We're looking at electron cloud of a carbon atom. And now, of course, what we know, this generation of our existence is based on carbon. Okay. The next generation may be based on silicon, but we are basically a carbon molecule, the multiple carbon molecules. And a lot of the living creatures are made of carbon. That's the main thing that we have. So why is carbon important? Because it has some chemical properties that help to build link structures. So we're getting smaller and smaller. Ooh, now we're into the realm of physics. Talking about electrons, protons. So this is 10 picometer, even smaller than nanometers. Now, these days, most of us may have heard of nanotechnology, right? We have advanced a lot. A lot of our medicine are made with nanotechnology. But this is beyond our day-to-day activities. We are looking at picometer. Okay? Much smaller than what average person would have heard of. But it's really a concept to us, but it's reality when you are in physics. Okay. We're getting smaller still, right? Seems to be an infinite amount of space between the electron orbit and the nucleus. Doesn't that beginning to look like the universe in reverse? Now imagine if we were one of the electrons and we are floating around. Okay. Now, do you think we can perceive the bigger picture of the so-called universe that we have? All right. Femtometer. Femtometer is actually even smaller. And I don't believe that, well, even electron microscopy can see this. Okay. So we can still go further. Now this is such a pictorial picture, a pictorial concept of what an atomic nucleus is. Wow. There seems to be nothing there. Okay, kind of all just dots, right? And this is what a proton would be. Now supposedly when we do physics and chemistry, we say a proton, that's like a solid piece, okay? But if we really go deeper into it, a proton is really just a bunch of mass. And there may still be a lot of gaps inside. So we go 10 to the minus 16th power atometer. Now we're talking about quark. So we are not at boson-Higgs yet. Again, it's just like reaching up to the 10 to the 25th power I think we can stop with that. Okay, so let's think about this. We go from very high to very small. Now, so are we the center of the universe? Years ago, the Earth was flat. Well, in the old days, Egypt was the center of the universe. Then it became Rome. And then, well, of course, in Chinese, we always think that, well, where the emperor is, the center of the universe. Okay? Are we meaning here, right? The human race. Are we really the center of the universe? Is the Earth, our sun, the center of the universe? Okay. Now, why are we kind of drilling on this? The next series of lectures will let us answer this question. Okay? Why are we, you, the center of the universe? Are you a special creature amongst the billions of other creatures in the world? In fact, and later on, this is one of Buddha's teaching. We will deal into that. What exists outside of our boundary? Is there any boundary? We talked about that last time. The boundary is our thinking box. Now, think about it. If we go down, exactly down means smaller, okay? We can only go as small as 10 to the minus 16th power. Right? I think that should be enough for lots of us. And reach the limit, or at least to the limit that is defined by modern science. I'm sure if we read through the scientific history, the boundary has always been expanding and actually contracting. Expanding into the universe, contracting, getting smaller and smaller as we went into from atoms to electrons to quarks, and now we have boson Higgs. So we are actually at our existing limit. That's not the limit. We know that. Now that we have broadened our horizon after the last lecture, we know that is not the boundary. The boundary, again, is just because of our thinking box. Yet we can follow our imagination and continue our journey as far as we want. Alright? So, who can say we are living alone in this universe? I think most of us these days are pretty open to this concept. Only the government doesn't want us to believe there's UFO. Right? We haven't found it. Well, I'm sure. Well, if you look at, Independence Day, the movie, Independence Day, you know that there is something coming one of these days. Alright, should we have a little discussion first? Chi, I'm sorry, you always get picked on first. You have the floor, Chi.
What do you...
Your feeling and your feedback.
From looking from this, I feel like everybody is not alone. It's just like when we look smaller, just like now in our blood, we have very tiny proton, neutron, but then we look at the bigger picture, we are the whole. So if you, from the space, you look down from the Earth, you just see the whole thing. You don't see every single person like us here. So everything, to me, is just like white.
Wow, that is powerful. Thank you, Chi. So I really appreciate the word whole. That is a powerful word, whole. Now let's get that sink into our heart. The word whole is really what a lot of the Buddhist concept is all about. Yeah, thanks. You are really enlightened. You're really special to have that word in your mind, just off like that. That's amazing. Whole.
I think we are all through your presentation, I can really see that we're all interconnected and interrelated with each other. And even though you and I are separate beings, if we look at what she said as a whole, everybody around us is part of a larger organism. And all our shared consciousness and everything that we do impacts the whole and beyond. So definitely at a vast, like I said, I have nothing to say sometimes. The universe is responding more and more and more, so it's just, I've reached the end, I think.
Well, I think Jing Xian can comment on that. That's kind of beyond my scope, Jonathan. You two are just fantastic. Jing Xian, can you make a comment? Can you comment on what we heard? Because that is really a fantastic insight and deep understanding of what Buddhism is all about. Thank you. Wow. It's only years, and you guys took 3 lectures to get it. We have basically asked some of our new members about their comments. And in fact, I think the word whole is actually illustrated by Gaian, right? Is it Gaian principle? Gaian? Okay, we'll talk about that, okay? The guy got that concept called Gaian. It's really talking about a whole. Everybody is interconnected, and so, you guys are way ahead of a lot of us. But he got the Queen's his honor in the 1960s. So we are probably 40, 50 years behind him. But we are catching up very quickly, okay? Thanks to Jing Xian and thanks to all the work of all the other seedings.
So the Gaia theory that Dr. Chen is talking about will be presented in our lecture about Is God and Ghost Real? Okay, which is metaphysics lesson, metaphysics lecture number 4. Okay, so we'll have a prelude to that, but the concepts are sorry. This is how we build up step by step to this curriculum. We've got the concept now, and then as we go into that area, it will be very clear. So let's take a 10-minute break.